Pretty interesting sessions this morning. Firstly, thank you everyone for making it on a Saturday morning. If you're working 5 days a week, if you're listening to AI throughout the week, again, you're listening to AI over the weekend, it might be overwhelming. But my objective today is to sort of really give you some insights to see where the industry is headed and some of the stuff that we're doing at GitLab that I feel would really help developers, the way they write code, the way they approach development in the first place. I'm rest assured that there are going to be some really interesting things that you take away from this session. I hope that happens. Right. So a little bit about me. I am the Senior Solutions Architect for GitLab. I cover APJ as a region. I work with a lot of developers like you in terms of the toolchain adoption, in terms of how they can improve their toolchain, how they can improve their DevOps, DevSecOps development processes, and yes, help them write better software, right? So that's really what I do as part of my work. And in terms of really the background that I had today was I just wanted to cover an AI native workflow and how sort of that really differs from a traditional workflow, right? If you can really understand that, then it becomes a lot easier for a lot of you to adopt the right tools in terms of your development processes, right? So over the last few years, if you see what's happening in the market, there's been an explosion of AI agents entering the market. Now, we have AI agents that are going to be writing code for your front end. You're going to have AI agents that are going to be writing code for your back end. You're going to have AI agents that are going to be writing your PRD documents, your user stories. So what we're really seeing is we have a lot of agents coming in, but these agents need to be managed somewhere from an organization perspective. They need to be orchestrated, right? So you can't have custom agents that are sitting and everybody's just defining their custom agents and doing what they want. So it becomes very, very disorganized. So what we felt in the industry was there were two distinct workflows that exist in the industry today. One is an IDE native workflow and one is a repository side of the workflow. So IDE is where the developer sort of writes the code, develops its code, and once the code is sort of written, it usually goes into a quality gating layer, which is where the source code management really comes in. That's where, from a CTO's perspective, from an IT manager's perspective, from a governance and compliance perspective, all the quality gating happens at the source code management layer, right? So if you really look at the goals of a CTO, really what he wants to do is he wants to build products faster. He wants to transform with AI, and he wants to secure software by default. Because by the time you release software into production, you want to make sure you're not releasing something that's really buggy and something that's really rich in vulnerability. So the problem statement that GitLab sort of really came into the industry is to solve this toolchain crisis that has sort of plagued a lot of software engineering teams. And what I mean by that is, when software engineering teams are really small, they start off with a plugin-based setup where they say, you know what, I start off with an SCM. If I want to extend my toolchain to maybe something else, I will get a plugin. Now, that really works well when you're prototyping your product, but when you've prototyped and you've built it, and when you're trying to ship it into production, and when you want to ship it at scale, and you want to, have more, predictable release cycles, that's when you start thinking of something like GitLab, where they can standardize some of those capabilities onto a single application and a single platform, right? So, so most environments sort of really look like this today, and with GitLab, what we really end up doing is we sort of try to eliminate that sequential DevOps problems that a lot of engineering teams have, right? The way we do that, I'm going to go through a sample workflow, and then we're going to delve a little deeper on in terms of what it sort of really looks like from an AI native development perspective. So typically what happens is an engineer would come in, there is a user story that's written, the developer would pick that up, based on that issue, he will write his code, that will go into a source code management. Once the code is written, it will go through a build system, something like Jenkins, it will produce some sort of an artifact, and then the CI/CD pipeline runs. And if at that point in time, if you see in this entire development workflow, one thing that traditionally happens is the testing happens after the build is completed. Testing generally doesn't occur when the developer is writing the code. So at this point in time, if some vulnerability is detected, that's fed back into the development loop as another issue, and then they would go through the development process again. Now, this fundamentally is a very inefficient process because in the industry, we use a term called context switching. So every time a developer needs to switch context from one tool to another, there is a certain amount of delay that sort of adds up in the overall development process. Now, if you measure the number of developers hours over months and years, that's a lot of developer productivity lost, right? So what we did with GitLab essentially is we decided that it's a much better approach for software engineering teams to consolidate some of those core capabilities, which is your software development, your security, your project management, and your platform operations. So all of those capabilities, if we give out of the box as part of one application, then there are some very big efficiency gains that you get. So this is really the fundamental workflow of GitLab. So this works well for a lot of software engineering teams because the total cost of ownership in terms of maintaining the toolchain is quite low. And for any additional capabilities that your engineering teams might need, you can expand out in terms of those additional capabilities, right? Instead of starting off stitching together multiple toolchains right in the first go, consolidate all your core capabilities first, and then you can expand out. And the solution for that was to go for an AI-powered DevSecOps platform, which is fundamentally sort of you have all those workflows interconnected, right? If you really look at the 4 personas that GitLab serves in the market today, that's really the software developer, which is the center stage of our product. Then we have the project manager, then we have our security operator, and then we have our platform engineer, right? So the benefit of doing that is when the workflow moves from one stage to another, there is the context of information also that is going through that entire workflow, right? So that's sort of really the primer of what I wanted to give people in the room on in terms of what we do as a product, what do we offer as a product in terms of the solution. But I should have asked this earlier, but in the room, how many people have used GitLab or are using GitLab as part of their workflow? Okay, nice, fair bit, nice, awesome. So let's sort of step into the next topic, and I'm sure because given the fact that most of you are developers over here, I'm assuming some of this information that you would already know, but this is again a primer to sort of give a background and then step into some of the specific areas. So if you really look at software development today, right, compared to where we were, maybe I'm sure a lot of people know how software development happened in the pre-AI era, but since last year and since this year, there are some very big changes that have happened, right? One was the birth of MCP this year that happened, and MCP allowed you to gather context of a lot of the external tooling. And the very big development that happened was the LLMs natively having bigger context windows, right? We started off a couple of years ago with maybe 20,000 tokens. Now we're talking about 270,000 tokens with Claude Sonnet 4.5, right? And this sort of really set the foundation for an agentic foundation to leverage a lot of these multiple agents together and then sort of orchestrate your workflows, right? So what a real development workflow would look like is something like this. So this is actually a real application that I sort of broke down into an agentic workflow piece, right? And you'd see that you have level 1 agents and you have level 2 agents. What that really means is I might initiate an agent which might spin up another agent underneath that. So I have the ability to nest multiple agents together and have the context of these agents be passed from one agent to another. So what we are really talking about when we talk about software development workflows is agent orchestration. And the agent orchestration becomes a really, really important piece because there are 2 foundational pieces to it, right? One is how do I manage context and how do I transfer that context from one agent to another? And then the other big aspect is how do I ensure that my agent is able to retrieve information so effectively that it doesn't go and search context each time. So one is the challenge at the control plane, and then the other is the challenge at the execution, which I call the data plane. Right? So this is sort of, I would say, still how the first version of agent-based development sort of really looked like. It's still challenging because there are very few tools out there in the market which could say that, you know what, how do we manage context? Once your context runs out, then either the new session has to gather the context again, or, you know, there has to be some sort of an external solution from where you need to feed in the context. So we're going to be talking about some of those things later in our session today. But essentially, this sort of really is where software development, the challenge with utilizing LLMs for software development sort of is existing today. Okay. Now, I spoke about this workflow earlier from a GitLab perspective. This is the fundamental workflow. On the left, you can see that every project development starts off from project planning. And as we progress through this entire workflow, you'll see at the middle is your developer layer, and at the far right, you have your platform engineering layer. So it goes through what we really provide out of a product is not necessarily a feature, but a workflow that we enable for a lot of development teams. Now, what we did with our Gen 1 AI is we decided to do some of these micro automations alongside the workflow, right? And why did we decide to do this? We decided to do this because we realized that there is not just the developer who's in the SDLC environment. There is the project manager. There are people who don't use the IDEs, right? I can't expect a project manager to come in and say, you know, why don't you use the IDE to use the MCP server to write your user story? Not going to happen, right? So what we realized at GitLab was we need to take an approach where we create AI native workflows for each persona. We don't give a tool with an AI workflow, but we create an AI native workflow that is very, very specific to that persona. Now, in this entire workflow, you'd see that there would be a different kind of workflow for a project manager. There will be a different kind of workflow for a developer. There will be a different kind of workflow for a security engineer. So all of them are using the UIs and the tools that they're comfortable with. But the fundamental, they can use MCP to connect. If they are comfortable with any other tool that they're using, they can obviously connect to our tool using MCP and they can gather the context. But that's really where that's how we are thinking about software development in general. We are not just focused on the developer and developer alone, because when a team sort of becomes bigger, you need multiple people to manage those different environments, and you need to give those personas the kind of UI that they are familiar with and they're comfortable with. That's really the idea behind doing this, right? So what we did as part of that was we transitioned from being just a source code management, something which has CI/CD capabilities, which has security capabilities, to now what we call an agent orchestration platform. So just think of it this way, right? You have, as a company, as an organization, you're going to have a whole bunch of agents, and those agents need to be managed centrally somewhere. Right? You can't have agents being created individually and which are disorganized, and agents doing, they will have very disorganized and broken workflows. So we decided at GitLab that it's better to centrally provide an option for customers to manage these agents, consume these agents, right? If there is somebody who's really good at writing agents, somebody who's written a good agent, we allow them to publish it in something what we call an agent catalog. Right? Once you are able to publish that in an agent catalog, there are other engineers, there are other developers who can come in and leverage that context, and they can pass around and use it in their workflows. So what we really see happening is the metadata of agents, which are essentially markdown MD files, and your application code are going to be sitting together in the SCM moving forward. It's not just going to be your source code, but it's going to be the metadata around it that becomes the human metadata and the agent metadata that's going to become really, really important. Are you with me, guys? Does that make sense? Yeah? So essentially, what we're looking at is a many-to-many scale environment where we're going to have, as I mentioned earlier, these agents are going to be living. You're going to have a whole bunch of agents that are going to be talking within the IDE. and then you're going to have a whole bunch of agents that are going to be residing within the repository. And why are the agents within the repository side of workflows important? Because that's where the quality gating happens. I, as a developer, individual developer, might use whatever agent I want within my IDE, but the moment I push that code into my source code repo, I will have a lead developer or somebody else who's going to be coming and reviewing that code, and I want to be able to provide a set of agents for that reviewer to review the code at an organization-wide level. So we're looking at that, M2A, many-to-many agents communication through MCP, right? MCP enables that fundamentally. But that's how we see the workflow for software engineering evolving, right? So if you really look at the AI native transformation that we're doing, I spoke about some of these things earlier, is we are going to have the agent catalog, and we're going to have those, provide the ability to have both first party and third party agents, right? And essentially, in terms of the UX, you'll be able to assign specific tasks to those specific agents, right? You can bring in the LLM of your choice, right? We don't limit the LLMs that the customer has to use, but we already have a predefined list of LLMs per se, but the customer has the flexibility to use the LLM of his choice, essentially, right? I think we've spoken about some of these things before. So essentially, the one very, very important piece of information that I wanted to convey is the source code management and the repository layer in your development workflow is essentially eventually going to become a system of record information. It's going to become a system of record because it's going to have the context of both the human data, all the code your developers have written, they're going to sit on that particular repository and that repository layer. So the idea is now when your code bases are likely to grow over time, how do you expect these LLM models to gain and retain context? So that sort of really brings us to a very important piece of the missing puzzle with the software development workflow in general, which is what we call the knowledge graph. So the knowledge graph is nothing but what I call a graph database. Now, what the knowledge graph really does is, and I'll show that to you in action as part of the demo, the small demo that I have. But if any of you guys in the room, I'm sure most of you guys use coding assistants to generate code, but you'd see that whenever it starts writing code, it will do a grep, and then it will start searching your entire code base, and then it will build the context, and then it will go ahead and change the files. And you'll realize that some of those things will get broken, and many a times if your code base is very big, it'll go into hallucination loops. And the reason that happens is because the LLM runs out of context at some point in time. So every time you start a development activity, and if it loses context, it has to go through that entire cycle over and over again, right? So this is very, very expensive in terms of token usage. It's actually very, very expensive in terms of time because it takes a lot of time to write even maybe change 2 lines of code for maybe in a file that is maybe 1,000 lines long, right? Think of it that way. So what the knowledge graph does is it essentially creates an index of your entire code base. So essentially what it's done is it's using the graph database, it's indexed the dependencies, the relationships of all the functions, classes, the files. The dependencies are, it's indexing it constantly, right? So because it has that relationship, the LLM model, before it starts writing the code, it actually doesn't need to query it doesn't need to scan the entire code base. What it can do is it just needs to query the database, and it can understand the relationship between one function and one class to one file to another, and it can exactly go ahead and make the change what is needed, right? Instead of going through that search, and that really is the one that consumes a lot of tokens and wastes a lot of time. So that is the fundamental problem that we have sort of solved with the first version of the knowledge graph that's come out just about 2 weeks ago. And we are having a phenomenal interest with customers, and at the enterprise level, a lot of these guys are exploring this. I'm also and I'm going to show you the performance improvements with the knowledge graph and without the knowledge graph. I've captured some data, and I can show you that to you. I can do a live demo, and I can show that to you as well. Right? So lastly, before I go into the demo, I want to talk about why do you want to go in for the Duo Agent platform, right? One, because it provides you that full context-aware AI within your software development lifecycle, right? And it has all the tools that are necessary for you to release a production-grade application right from day one, right? Many companies, after they've sort of really have a plugin and they've invested in their tools from a plugin-based architecture environment, they realize over time that's actually very expensive for me to have so many tools. So save the cost in terms of your tool chain, invest that cost in stuff that is needed, consolidate your core capabilities, and then expand out. That's really is the messaging with what I wanted you to have with GitLab. With that being said, I want to just go into a sample demo of how the knowledge graph really looks like. So if you really look at this is my code base here today, and I'm using Claude Code for my development. For some reason, I'm not able to see my chat because I am here, right? So if you look at this, my code base, visually what the knowledge graph looks like is something like this, right? So if you look at this, if I zoom this, I can actually see what is the dependency of my application with each other application. So it's basically indexed this entire thing, right? And what I've done is I've configured the knowledge graph here as an MCP server. So essentially what I can do now is I can just say /MCP, and I'm just going to check it if my MCP server is running. And I can see that my GKG MCP is running. And I just ran a demo just to save some time over here around what is the performance improvement that you get. And you can see the moment I initiate anything, it calls the MCP tools, but really what I wanted to show you was this particular aspect, right? So I did a performance test summary with the GitLab knowledge graph, and without the knowledge graph, you can see the code discovery took close to about 0.3 seconds compared to 5 minutes in terms of code discovery without the GKG. Right? In terms of the error rate, it was less than 5%, and without GKG, it's about 30 to 40%. Right? The implementation cycle is 1 pass, 3 to 5 pass. Even this is something that even I don't understand yet, but the improvement is almost 1,000x faster because I have completely indexed my entire code base. Right? The LLM model will not go ahead and read each and every file before it can go start its development activity. So even if in this kind of an approach, if it loses context, your LLM loses context, it has the ability to gain back that context back just by simply coming and querying the knowledge graph. So essentially what you're using your LLM is just for execution. Your context, your dependency on context is not as much. You can store that context outside also, it doesn't matter, right? So the other important thing that I wanted to show you was, so this is again, I mean, these are React components that I did. So it basically indexed all of these things. So what it can do is, it can pretty much, there are a couple of limitations because this is the first version right now. There are a few languages that we support. There are certain limitations with React. There are workarounds around it. But the idea is, I just wanted to show you how this really looks, and I hope you guys will use it within your development workflows, right? In terms of the languages that we support, right? This is what we support out of the box today. We have Ruby, Python, TypeScript, JavaScript, Kotlin, and Java. This list is going to increase, but over time. But this is a complete game changer, guys. I've been vibe coding for the last 6-8 months, right? And the kind of improvement that I have seen with the knowledge graph, I have not found that in any external tool. We simply don't have a solution in the market yet which can address that, right? So please try it out. That's all I had for you. If you have any questions, I'm outside for the next 1 hour, and I'd be happy to take your questions. Thank you so much.